Okay, I think I'm live now. Can someone confirm if I'm live? Yes, okay. Okay, cool. So we're gonna be solving educational code forces round 127 today. It's a Div-2 round, and I'll be doing problem A, B, C, and D. Okay. Before that, I'd actually like to know like how many problems you were all able to do today. I see only 8 people are watching the stream right now. Why is that? Usually it's like 30 people at least in the start. Okay, I'll wait for a minute for more people to join, and then we'll start. I'll start from problem A. We'll move in order only A, B, C, and D. How was it for you? For me, it was good. Like I did ABC very fast, but for D, I took a lot of time, which I shouldn't have. And then for problem E, I actually got stuck with the input only. Like I couldn't understand the input, and that's why like I wasted all my time. Okay, start with C, please. No, I would. I'll actually start with A only. Okay. All right. Okay. So D से start करो. No, I'll start from A. Okay, sir. Okay, cool. Okay, 3 solved. Okay, cool. All right, let's start now. I'll start with problem A as usual. Okay, cool. Okay, you're given a string S. You have to determine whether it is possible to build the string S out of strings AA, triple A, double B, or triple B by concatenating them. You can use the strings in any number of times and in any order. For example, this is actually made up by using 2 times twice A and then a triplet of B. And similarly for all the other examples. Okay. Now, if you see, you can actually make any kind of a string except when there is a single A or when there is a single B. Because since you can make you can add 2 A's consecutively, that means you can even add 4 A's consecutively by adding 2 times twice of A consecutively. Okay. So the only pattern that you cannot make is that if you have like ABA or you have BAB. Because in this you needed a single B and in this you needed a single A. Okay, and since you didn't have any single element, that's why you need to take. Okay, cool. And that's precisely all you had to do. So for example, in this case, okay, if you see you had a single B in the end, which that's why this is not possible. Similarly for this one, similarly for this one, similarly for this one also. If you see you had a single B here, then you had a single A here, and so on. Okay, so I'll quickly show my code as well. I'm pretty sure like everyone was able to do this problem. Okay. Okay, so this is the code that I wrote. So I first scanned the complete string. Then for the complete string, I'm actually starting from index 1 till n minus 1, n minus 2th index. The reason for that is because I cannot check the first and the last string because they are the corner cases. Okay, so for them, I just checked if the value on the left is different and if the value on the right is different. If both the side values are different, that means I can say my flag is 1, and when my flag is 1, I have to print no. Otherwise, I need to check for the corner cases. Okay, what if it's my very first element in the string which is wrong? Okay, then I just need to see if it is not equal to s of 1, and same for the last index as well. And then this is also one case that if n equals to 2, you just make flag equals to 1. Okay, I made penalty of on first thought only multiples of 2, 3, 5 works. No, 4 will also work, and so on. Okay. You can first sort the okay, that is for a different question, I think. Okay, cool. I think problem A is clear to everyone now, and we can move on to problem B. All right. If someone wants my code, they can just go to my Codeforces submissions and they can just get the code. Okay. Coming on to problem B, you're given n points with integer coordinates on a coordinate axis O2x. The coordinates of the ith point is xi. All points coordinates are distinct and given in strictly increasing order. Now, for each point I, you can do the following operation no more than once. Take this point and move it by left to the left or to the right. Okay. In other words, for each point you choose its new coordinate. For the ith point, it can either be xi minus 1 or xi or xi plus 1. Okay, okay, so basically if you had an element x, you can either make it x minus 1 or you can either make it x plus 1. Now you have a complete array of elements. You have a0, a1, a2 till an. Okay, now you need to change every element either to this or keep it same, such that this complete becomes a segment, consecutive segment from L till L plus n minus 1. For example, like if it is 4, then the next element becomes 5, 6, 7 till SA till n. Okay, so this is what you are supposed to do. Now, how to do this? If you see, okay, if you see my very first element, it can either be made a0 minus 1 or a0 plus 1. The very last element can either be made an minus 1 or an plus 1. Okay, what I need is difference of these, okay, should be equal to what? N. Okay, so what is the maximum number of elements that I can actually contain? Okay, first let's see what is the length of this. The length of this is actually an minus a0 plus 1. This is the complete length of this string. Because let's say if it was 4, 5, 6, 7 and 8, the length of this string would have been 8 minus 4 plus 1, which is 5, because we had 5 elements. Okay, oh sorry, I actually removed my video. Okay, cool. Okay, so the length of this string is actually equal to an minus a0 plus 1. Okay, and for example, let's say we had from 4, 5, 6, 7, 8, then it would have been 8 minus 4 plus 1, which is 5, and 5 is the number of elements. Okay, now what is the total maximum number of elements that you could have in this? If you decrease this value by this, increase this value by this, what is the total number of elements you would need in the middle? Okay, so this is a of n plus 1, sorry, a of n plus 1 minus a of 0 minus 1. Okay, so these are the total elements that would actually come in between. Okay, so if you're increasing this, you need to increase this as well. Okay, and this becomes minus 1 because that is the total length of the string. That means if this is equals to this value, yeah, like actually this is equals to the value only, then only your answer is possible. Is this clear? I don't really know like what you're trying to say. Is this clear to everyone now? Yeah, if this value is less than equals to n, then only you have like, then only it is possible, otherwise it is not possible. Clear? Rohan says clear. Okay, cool. Okay, and that's it. Okay, that is the entire logic of the complete problem. Okay. Okay, I think we can move on to problem C now. Again, like this problem was pretty easy if you actually like had a good perspective of the problem, like what they're actually trying to do for every operation. Okay, all right. Okay, cool. Okay, let me even show you the code. So if you see, this actually becomes a of n minus a of 0 minus 1. Okay, so if I show you my code, so this is the code. So I took the first element in the like a of 0, array 0 becomes my a, array of n minus 1 becomes my b. Now if b minus a minus 1 is less than equals to n, okay, then only my answer is possible. Not clear? Okay, we know that every element is different and they're strictly increasing. That means you have all the elements in the middle, you just need to arrange them, or not arrange, you just need to either increment a little more. Okay, you already have n elements in the middle. Okay, if you already have n elements in the middle, okay, that means the difference of these should also be equals to n. Okay, now if you're increasing this element by 1, if you're increasing a of n by 1, that means you need to increase a of 0 by 1 as well. Or if you are decreasing an an by 1, then you need to decrease a0 by 1 as well. And that is how you get this logic. If I show you, it is mentioned in the problem. Just a second, let it open. Okay, I'll explain. As you can see in the board, if you increase the n by 1, then a0 should also be increased. Difference of this minus 1 should be less than equals to n. Okay, I hope this is clear to everyone now. I don't have CSN to because you've been advised. Should I take CSN engineering? Anybody in comments? Okay. All right. Why n? Why n? The reason is because the number of elements have to be n. Okay, I think many people are getting confused, like why I'm doing this. How do I explain this? Okay, so basically, what I'm actually doing is I'm taking my last element. Okay, what I can do with it? Okay, I can either increase it or decrease it. Okay, if I increase the last element, that means I need to increase my previous element as well. Okay, so I increase my previous element as well. Difference of this, or I actually have a better way. Okay, there are two cases. One is if this complete array is already like strictly increasing and consecutive, then its answer is n. Good. Okay, then it would be a of n what minus a of 0 plus 1 will be equals to n, right? But it might be that now we also know that these are strictly increasing elements. That means a of n minus a of 0 will be greater than n if they are not consecutive. In order to make them consecutive, what you can do is you can either increase this an. Okay, if you increase this an, okay, if you increase this an, what does this become? A of n plus 1. Okay, this remains the same. What? Minus a of 0. This should be equal to n. But this is not possible. The reason is that you'll always have to decrease this value. Because if you increase this value, that means this is never going to make a sequence. Because all these values were strictly increasing. That means you can only decrease this value by 1. Okay, is this clear? My approach was calculating. Okay. The other cases, what if we had to decrease this also and decrease a0 as well? Then it would be a of n minus 1 minus of a of 0 minus 1. This is a of n minus 1 minus a of 0 plus 1. This is equals to n. Sorry, this is plus 1 and this is minus 1. Because you have to increase a of 0 to make it closer to the next value. So this becomes a of n minus a of 0 minus 2. This should be equal to n. So instead of writing, like other condition was a of n minus a of 0 minus 1 should be equals to n. Instead of writing both of these conditions, I just wrote that a of 0 minus a of n minus a of 0 minus 1 should be less than equal to n, and I eliminated this condition. And that's it. All right, I think this is clear to everyone now. Okay, I didn't really think like it would be this complicated to explain. But yeah, that was the general idea of this problem. And I think we can move on to problem C. I'll just quickly show my code as well for the last time. Okay, so basically what I'm doing is, this is my last element, this is my first element. So I'm just taking b minus a minus 1. If this is less than equals to n, then my answer is yes. Otherwise, my answer is no. That's it. All right, let's move on to problem C now. Okay. Y less than n is equal to n should be here. Because the difference can either be like either a of n minus a of 0 minus 2 should be equal to n, or a of n minus a of 0 minus 1 should be equal to 1. So I just wrote a of n minus a of 0 minus 1 should be less than equals to n. Okay, cool. There are n shops around that sell sugar. Okay, you need to buy sugar. There are n shops that sell sugar. The ith shop sells any pack of sugar for AI coins, but only one pack of one customer each day. So in order to buy several packs, you need to visit several shops. Another problem is that prices are increasing every day. During the first day, the cost is AI. During the second day, the cost is AI plus 1. During the third day, it is AI plus 2. So basically, we had, like, let's say A1 cost. The next day, the cost become A1 plus 1. The next day, it became A1 plus 2, and so on. Okay. Now, on the contrary, your everyday budget is only X coins. In other words, each day you go and buy as many packs as possible with total cost not exceeding X. Note that if you don't spend some amount of coins during a day, you cannot use these coins during the next days. Eventually, the cost of these packs will exceed X, and you won't be able to buy any single pack. How many packs will you be able to buy till the moment in total? Okay, so let's take the very first example only to understand this. So let's take this example. So initially, we have 3 packs. The first pack costs 2. The last, okay, let's sort these. The second pack costs 2 also, and the third pack costs 1. Okay, or I'll actually write it like this: 1, 2, and 2. Now this is day 0. Okay, this is day 0. On day 1, or on day, this is day 1. Okay, on days 2, or let's see, wait. So this is day 1. Okay, so we have 1, 2, 2. Okay, and this is at day 1. The cost of sugar at day 1 at first shop is 1, at the other one it's 2, and the other one is 2. Our X is 7, that we have 7 in the pocket at the moment. Using this 7, we can actually buy one sugar this and one sugar this. That means, okay, yeah, we were able to buy one packet this sugar, one packet this sugar. Now let's come on to day 2. On day 2, this cost became 2, this cost became 3, this cost became 3. On day 1, we actually were able to buy all the 3 packets. 1 plus 2, 1 plus 2 plus 2 is actually 5. And since we had 7, we were able to buy all the 3 packets. Then on day 2, the cost became 2, 3, 3. Now we are able to buy this packet and this packet only. The reason is because 2 plus 3 is 5, and if you add this 3 also, it becomes 8. Therefore, it is better to buy only this packet and this packet. Next, let's come on to day 3. The cost now becomes 3, 4, 4. Now you are able to buy this packet and this packet again, because 3 plus 4 is equal to 7. Okay, now let's come on to day 4. The cost becomes 4, 5, and 5. And now if you see, you are only able to buy this packet. The reason is because if you try to buy this packet, it will be 4 plus 5, which is 4 plus 5, which is actually 9. Therefore, you are only able to buy this one packet. So on day 5 now, it becomes 5, 6, 6. Again, you are only able to buy one packet only, which is this one. Okay, this packet. Now on day 6, again it becomes 6, 7, 7, and on day 7 it becomes 7, 8, 8, and on day 9, day 8, it becomes 8, 9, and 9. Okay, on 6th day you are able to buy this one, on 7th day you are able to buy this one, and on 8th day you are not able to buy any packet, and so you stop. Now, what is the total number of packets you were able to buy? So we were 3 plus 2 plus 2 plus 1 plus 1 plus 1. 3 times 1. Yeah, okay. Sorry, 4 times 1. Okay. And this is actually what? 7, 8, 9, 10, 11. This is 11. That means you were able to buy 11 packets of sugar in total. Now, how to do this? Let's say we had a day 0, and on day 0 the cost of the very first sugar was 0, this was 1, and this was 2. Sorry, this was 1. And on day 1 the prices got increased and the prices became 1, 2 and 2. Okay. Now, in order for us to buy the very first packet at any nth day, okay, so the cost of the very first packet is A0, let's say. Okay. Or let's say the cost of the sugar at the very 0th day is 0. Then the cost of this packet at any nth day would be 0 plus n. Because if you see, on 5th day it was 5, 6th day it was 6, 7th day it was 7. If this total value is what? Less than 7, that means I am able to buy sugar, this packet of sugar, on nth day. That means maximum it will be when they are equal. That means n is equal to 7. That means till 7th day I am able to buy my first packet of sugar. That means my very first packet said that you can buy this packet 7 times. What about the first packet? We will only buy. What about the second packet? We'll only buy this packet when we are able to buy the previous packet also, because the previous packet had a cost less than equals to. Now, at any given day, what is the cost of this packet? At any given day, the cost of this packet is what? We started from 1 because at day 0. So 1 plus increment is n. Okay. But we also know that in order to buy this packet, we first need to buy the previous packet as well, which means 0 plus n as well. If summation of this is less than n or less than x, that means till that day I'm able to buy my packet from this shop as well. X is 7. This becomes 1 plus 2n. Okay. So 1 plus 2n should be less than 7. That means n is equals to 3. At max, n is equals to 3. And at day 3, if you see, you are able to buy the last packet of sugar from this shop. Similarly, let's see till which day we were able to buy a packet from the third shop. Now, in order to buy a packet from the third shop, we know that we need to buy a packet from the second shop also and from the first shop as well. Which means increment of first shop is this, second shop is this, increment of first shop is this, increment of third shop is going to be 1 plus n. This actually becomes 2 plus 3n. If this is equals to 7 or less than equals to 7, that means till that day we were able to buy sugar from the third shop. If you see, n here will give you 1. And at n equals to 1, at day 1, we were able to buy the last packet from this shop. This effectively means that for the very first shop, it was 0 plus n should be less than equals to 7. For the first shop, it was 1 plus 2n less than equals to 7. And for the third shop, it was 2 plus 3n less than equals to 7. You have to find the value of n in all these conditions and add them, and then you get the final answer. What is this 0, 1 and 2? This is nothing but sum of all the shops previously. So if this is my first shop, this is my second shop, this is my third shop. Okay. Prefix sum of my first shop is 0 only. Prefix sum of my second shop at day 0 is 1 because 0 plus 1. Prefix sum of my third shop at day 0 is 0 plus 1 plus 1, which is 2. And that's it. So you had to run a loop. For every shop, you had to see like what is the maximum day till which I am able to buy sugar, and then just keep on adding the answers. Before that, you need to sort all the values of sugar cost. Okay, because you need to buy the minimum cost sugar packet first. Why is 0 1 2 the sample? No, the I made it 0 1 1. The reason for that is because we had 1 2 2 at day 1. So I suppose that at day 0 the prices were 0 1 1, because at day 1 the prices got increased by 1, and this 0 became 1, 1 became 2, this 1 became 2. Okay, I hope this is also clear to everyone now. Uh, Kind of a creative problem, I would say. And let me even show you my code as well now. What I'm essentially doing in the code. Okay, so basically, the very first thing that I do is I first complete my complete array, and I decrement my array value by 1. The reason for that is because I need to know the value at day 0. Instead of knowing the value at day 1, I need to know the value at day 0. Okay. Now, I sorted the complete array. Now, for every index I need my sum of all the previous values. So this last plus array I is actually giving me the sum of all the previous values. Okay, I subtract that value by, okay, let's me just make this formula also. Okay, so let's say we wanted to do this for any ith index. So for any ith shop. Okay, and let's say that we started from A0, then A1, then A2, then A3, or let's say A0, A1, A2, and then A3, and so on till A of I. Then what is the cost for this A of I? Prefix cost. So, okay, so we need to add A0 minus 1 plus A1 minus 1 plus A2 minus 1 till A of I minus 1, because this is the cost of all the shops at day 0. Now every shop, the cost of every shop is incrementing by 1 every day. And since we have I number of shops, okay, I plus 1 number of shops, because we are 0 based indexing, that means we need to add I plus 1 as well. For every day, one day, I plus 1 is getting added, because 1 is adding to this one, 1 to this one, 1 to this one. So in total, I plus 1 is added. And for n days, for n days. Got it? So what does this? This should be equal to x or less than equal to x. So this actually becomes, I already decreased my A0, A1, A till by 1. So let's remove this minus 1. Okay. So this should be summation of AI for I equals to 0 till I, for AX, let's say x equals to 0 till I plus I plus 1 times n should be equal to x. So this actually makes x minus this sum, okay, summation of a of x for I equals to 0 till I x equals to 0. This summation, when divided by I plus 1, will give me n. And that is what I'm actually doing. If you see my code, I am actually doing, so last plus array I is actually giving me the summation of all the previous elements. Okay, I subtract that with the x, then I divide this by I plus 1, because we have I plus 1 elements, and then I add it to the answer. Before that, I'm just checking if this is giving me a positive answer. If it is giving me a positive answer, then only I add. Which means that this is the maximum day. This is the maximum day till which I'm able to buy sugar from the ith shop. And then I just add array I to my last, because my last contains summation of all the previous values. And then you just print the answer. I hope this is clear to everyone. Sir, please zoom the screen. Okay, cool. I don't know, like this zoom. Okay, okay, cool. I hope it is visible now. You can just see this code. Okay, so do you stream after every Codeforces contest? I try to stream after every Codeforces contest, but yeah, I do miss some contests as well. Okay, cool. I hope this is also clear to everyone. Okay, cool. Okay, I think we can move on to problem D now. Can we? Understood. Rachit says understood. Perfect. Clear. Okay, let's move on to problem D then. Okay, let me just zoom out. And problem D. So you are finding for each shop. Yes, I'm finding for each shop. All right. For problem D now. You're given a sequence of n integers, a1 till an. You're also given x integers 1 till x. You're asked to insert each of the extra integers into the sequence A. Each integer can be inserted at the beginning of the sequence, at the end of the sequence, or between the elements. Okay. The score of the resulting sequence A dash is the sum of absolute differences of adjacent elements in it. What is the smallest possible score of the resulting sequence A? Okay. So let's take the very first example again. And let's take this one only. So we were given what? One element, which is 10. And we were given elements from 1, 2, 3, 4 and 5 as well. Now we need to arrange all these values in such a way, we need to insert all these values in this array in such a way that the summation of the consecutive difference is least. Now for this one, the answer is actually going to be 1, 2, 3, 4, 5 and 10. Difference of these two is 1, this 2 is 1, this is 1, this is 1 and these two is 4. Sorry, 5. And summation of all these values become 9 and 9 is the answer. Let's take the next input. Okay. Let's take this one. Okay. For this one, we have 3, 8, 3 is n. So we have n is equals to 3, x is equals to 8 and then we have 7, 2 and 10. And we have numbers 1, 2, 3, 4, 5, 6, 7, 8. Now there are multiple ways through which we can do this. The core idea is that since we need to find the adjacent differences, so insert every element where it has the closest value. Okay, so for this one I'll just insert and then show you. For this one the answer would be, so we had 7, 2 and 10. Okay, so what you can do is you can actually take 7 again, 6, 5, 4, 3, 2 and insert them here. Okay, then you are left with 1 and 8. You can insert 1 here and then you can insert 8. If you see, the difference of this is 0, difference of these two is 1, 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 then again 1, then 0, then 1, then 7 and then 2. So you had what? 5 ones. So 5 plus 1 plus 7 plus 2, which is 15, and 15 is the answer. Okay, now how to do this problem? Let's forget about the constraints. Okay, let's say you had a0, a1, a2 till an. Okay, or a1. Let's start from a1. And let's say you had 1, 2, 3, 4, 5 till x. An ideal case would have been you would take every element, insert it to its closest value, and then make the complete array and then find the consecutive differences, and that would be the answer. But the issue is that n is actually, okay, both n and x are less than equal to 2 into 10 to the power 5, but you have test cases 10 to the power 4, and it is given that summation of n is less than equal to 2 into 10 to the power 5. So let's take a case in which n is equal to 1, let's say t is equal to 10 to the power 5, and for every test case x is equal to 2 into 10 to the power 5. So for every test case you would actually have 2 into 10 to the power 5 plus 1 elements. Since there were 2 into 10 to the power 4 test cases, total number of elements would be this times 10 to the power 4, which actually makes 10 to the power 9 elements, and hence it would give you a time limit. So we need an optimized way of doing this. Now how to do this? Let's take the previous example only. We had what? 7, 2 and 10. Okay, and x was 8. If you see, every value which is between 7 and 2 can be inserted here, and it will give you the best optimal answer. The reason for that is because even if you have 5 in the middle, okay, the difference of 7 and 2 was earlier what? 5, but the difference of 7 minus 5 plus difference of 5 minus 2 is also 5. So every element which you have which is in the middle of 7 and 2, you can insert it in the middle of 7 and 2. Similarly, every element that you have which is in the middle of 2 and 10, you can insert them in the middle of 2 and 10, and the answer won't change. Okay, so essentially, if you see, you'll actually get segments. You see that you can insert every element from 2 to 7 here, every element from 2 to 10 here. And since both of these are actually like mixing, what overlapping sequences, you can say that every element between 2 to 10 can be inserted in this sequence. Okay, now let's make a graph. Let's say I made this graph, okay, and I said that this was my very first value. Let's say this is A0. Let's say my A1 was here. Let's say this was 2, this was 4. My next element can be either greater than 4 or smaller than 4. Let's say it was smaller. Let's say it was 1. So this is A2. Then again, let's say the next element was somewhere here, A3. Let's say this is 3. So ideally, your array was what? 2, then you had A1, which was what? 4. Then you had A2, which was 1, and then you had 3. What are all the segments that we are able to make? We are able to make a segment from 2 to 4. We are able to make a segment from 4 to 1, which is actually 1 to 4. We are able to make a segment from 1 to 3. That means every element between 2 to 4 will be inserted here. Every element between 1 to 4 will be here, and every element from this to this will be here. But if you see, these are all overlapping sequences. That means every value between 1 and 4 is covered somewhere in these values. Therefore, from this list of 1 till x, you can actually remove this segment. And you just need to find the values for the remaining elements. What is this 1? This 1 is nothing but the minimum of this array. This 4 is nothing but maximum of this array. So that means every element from your min till max, and let's say this sequence of x started from 1 and you had some values and you had till x. So your segment from minimum to maximum is covered somewhere in the array, and you don't really need to put them into the array because it will give you the same answer only. Now you're only left with this starting part and this starting part. Okay, now where to add this starting part and this starting part? Okay, now we know that, okay, let's say in the complete array we had minimum value somewhere here, or let me call this what? M. This was the minimum value. We know that in this sequence also we'll again have M, and we will insert them, that M, right next to this M, either on the left side or on the right side. What if we take all the elements, these elements, and insert them in the middle? So you have M, M minus 1, M minus 2 till 1, and then you have another M. Okay, similarly for the max also. When you had max, you would always have another max inserted right to the left, to the right or to the left. You can take all the elements from max plus 1 till x. So you had M plus 1, you had M plus 2 till x, and then again M. This will be the most optimized way of inserting these elements. The reason for that is because, let's say for this one, we know that no matter we insert these values on the left side or on the right side, this difference will always be there. So like this is 1, this is 1, this is 1, so on, and summation of this complete difference will be M minus 1. But this difference might change depending upon if you took this complete length on the right side, or like meaning on the middle or at the left of this. But we know that every element which is on the left of this will be something greater than M, because M was the minimum element. That means this M minus 1 will be smaller than whatever difference that you get from here. Okay, and this is nothing but 2 times M minus 1. Okay. Now, okay, cool. And similarly for the maximum also. So you need to do 2 times max element. Let's say you had max element minus 2 times x minus max. x is the value till which you are going, max is till which we have already gotten. So this is max, this is max, this is also max. So you inserted all the remaining elements in the middle. Okay. What is x is less than the minimum value? What if x is less than the minimum value, that means you won't have the segment only. That means you only need to take care of this left segment, and that's it. You don't need to take care of this one. I have taken this case so that we have both the segments. Can you explain with an example, please? Okay. Which example should I take? It's a little difficult to take an example. Okay, let's take the third example, the last example. Okay, so we had 1, 3, 1 and 2. Through this we knew that our minimum element is 1, our maximum element is 3. That means every element between 1 to 3 will be inserted in the middle of any of these elements, and the answer will be 1 minus 3, sorry, 3 minus 1, which is 2, again 3 minus 1, which is 2, then 1 minus 2, which is 1. Okay, so this 5 constitutes 2 differences of all the consecutive elements here, plus differences of all the elements between 1 and 3 which were inserted from this set till here. Now apart from this, you also have, okay, so we took all the elements between 1 and 3 and placed them. Apart from this, we have elements, x is actually equals to 10 in the case we are taking in this, x is equals to 10. That means we have 4, 5, 6, 7, 8, 9 and 10 still left. Okay, now you can either take all these values and insert them right next to the largest element, which is this 3, because we know that if we have a 3 here, that means we'll either have a 3 here or here. So let's say we had a 3 on the right side. So we can take all these elements, put them right in the middle, and there is a possibility that we might get a better answer. Or we can just take all these elements and place them in the end or in the start. Is this clear? Okay. Is this clear to everyone? So essentially what I'm doing is I'm finding the minimum element, maximum element. Through minimum, maximum element, I know that all the elements in the middle of these will be inserted, auto-inserted in the array, and the answer won't change. Then you're left with the starting sequence and the left sequence. And for this, you have multiple scenarios. Okay, either you can take the starting sequence and put it in the very start, or you can take it and put it in the very end, or you can take the smallest element in the array and then put it right next to between two smallest elements. If you put them right next to two smaller elements, the answer will be 2 times minimum value minus 1, and for max it will be 2 times x minus max. Okay, now let me just show my code as well. Okay, let me increase the font again. Okay, so this is what I'm doing. Okay, let me just explain this. Okay, so basically we had the complete array here. I found out the minimum element and then the maximum element. Okay, then I just inserted all the different consecutive differences because we need those differences. Okay, that is the at least value we need. Then we know that we have already inserted all the values between minimum and maximum. Okay, now we need to take care of all the elements from 1 till minimum and from max till x. So let's first look at all the values from 1 to minimum. Now there is a possibility that my minimum element is present. Okay, you don't really need this much part, you just need this part. Okay, what you need to do is, your answer will be either 2 times minimum minus 1, considering that this minimum is present somewhere in the middle, or you can actually insert all the values in the start or in the end. Okay, now if the starting is smaller, if you know that this is 1 and this is 2, that means it is better to put all the small elements before this. So you'll put like 1, 2, 3 till this, and if this is minimum, you'll get a minimum here. Okay, so you just find out the minimum element of array of n minus 1 and array of 0 and then subtract this by 1. Okay, because your starting was from minimum and your ending was at max. If you insert all the elements from 1 till minimum here, the difference of consecutive difference of all these elements is actually going to be minimum minus 1. Okay, my screen is not visible. You had the string from minimum till max already computed. Okay, now if you take all the elements in the very left, you will have 1, 2 till minimum, and the difference of all these values is minimum minus 1, consecutive summation of consecutive differences. Similarly for this one also, if you put x here, the difference will be x minus max, and that is what I'm doing. Okay. So for this, if you put it in the middle, the summation will be this one. If you put it either on the left side or on the right side, it will be this one. Similarly for maximum element also. Now before that, you need to check if your x is greater than max, because then only you'll have a right segment. Okay, then again, you don't need this part of the code, you just have to write this one, that if you put all the remaining elements in the middle next to maxi, next to the max element, then it will be this one. Else you can actually have it in the left part or on the right part. Okay, now whichever of the array 0 or array n-1 is greater than it is beneficial to have all the remaining elements on that side. So that is what I'm doing, x minus maximum array of n-1 or array of 0, and then you just print the answer. Is this clear? Rajat says okay, Nazim says clear, Rajat says thumbs up. Okay, cool. I think this is also clear to everyone now. And with this, we are done with problem A, B, C, and D of the contest. Kasha is actually thinking of some method to remove all the elements from 1 to x which are between any two pair of adjacent elements in the array. Didn't thought of overlapping. Yes, you had to think of overlapping. After that, you had to see that actually all the elements between minimum and maximum will be overlapped. And then you will be only left with one left segment from 1 to minimum, and then one right segment from maximum till x. And that's it. Okay, cool. All right. I think that's it for the stream today. We did problem A, B, C, and D in the stream. I don't think problem E and F are to the scope of the stream. Even I have to upsolve E at the moment. I don't really know the answer. Okay. And I think we are good to end the stream. Do like the stream, guys, and please subscribe to the channel as well. We have a contest tomorrow also, I think. Let me see. Yes, we have a contest tomorrow as well, and it starts at 7:35. So I'll probably come live at 10 p.m. tomorrow, and we'll do. Okay, it is, and yeah, it is rated, and it's a global round. Okay, cool. So I'll start at 10 p.m. I'll start the stream at 10 p.m. Okay. Oh, sorry, it's a 3-hour contest. So I'll start the stream at 11 p.m. and then let's see how much length it goes. All right, cool. Thanks for watching, guys, and do subscribe to the channel if you find this stream useful.